Welcome, I'm Carl Frame. I'd like to introduce you to two new and rather unique online courses in the materials aspect of nuclear energy that's being offered by the University of Kansas Continuing Education. The two courses are Materials for Nuclear Energy Applications and Corrosion and Degradation of Materials in Nuclear Energy Applications. Rather unique. I don't think there are any other courses out there quite like these. The background for these courses goes back to a need perceived by the nuclear power industry and by the U.S. Nuclear Regulatory Commission. Uh, Under a pair of grants to the University of Kansas from the NRC, three courses were developed. The two I've just mentioned, and another course, The Effects of Irradiation on Electronic Materials and Devices. So they were developed under this grant. They were taught in the classroom at both the undergraduate and graduate levels by the Mechanical Engineering Department of the University of Kansas. So these two grants really were meant to answer a need that the NRC and the industry perceived. Materials for nuclear energy applications and corrosion and degradation of materials in nuclear energy applications are now offered by the University of Kansas Continuing Education as on-demand online video courses, not taught in the classroom. Basically, during the 1980s, 1990s, and beyond, there was a real dearth of construction of new nuclear power plants in the United States of America, not so much overseas. And because of that, few students in universities went on to study nuclear engineering. So engineers were not trained in this particular area during that time period. The engineers who were trained earlier than that and entered the profession and the industry are now reaching the age where they're retiring. So we have a demographic problem here. There is a growing population of younger engineers now in the industry and in the nuclear Navy, but they have not had specific training in the depth that they need for the nuclear industry, and hence the need for these courses. So few of the engineers out there now have taken any materials courses specifically focused on the nuclear energy field. They've had general materials courses typically, but not specific to this field. And as far as I know, there are no other courses quite like this available out there at this point in time. Our reactors, for the most part, in the nuclear power industry are aging. They've been around a long time, so these topics of degradation and the materials aspects in the nuclear energy field are really becoming very important. Materials for Nuclear Energy Applications is a comprehensive study of the effects of irradiation on materials that are used in nuclear power reactors, as well as materials that might be used in the future, and the related equipment in these systems. And really this course starts at the atomic level and then proceeds to microstructural changes and property changes. It covers the effects of irradiation on the full range of mechanical properties, including strength and hardening, fracture and embrittlement, creep and growth, and stress corrosion cracking. It covers non-destructive testing as well as other analysis tools that may be semi-destructive or destructive. It covers preventive maintenance and a number of real-world case history in quite some depth. And finally, it covers the thermodynamics of nuclear energy production. It is equivalent to a full semester university course in the number of hours of exposure, which is 30 plus hours of classroom or lecture time. It is not in the classroom. It's basically in the same format as you're seeing right now. This course is presented in 6 modules with 19 lessons. Module 1 is Introduction to Nuclear Energy Production and Materials, 2 lessons. Module 2, The Effects of Irradiation on Materials, in 4 lessons. Module 3, The Effects of Irradiation on Mechanical Properties and Corrosion, in 4 lessons. Module 4 is Testing, Analysis, and Preventive Maintenance, on 3 lessons. Module 5 is Case Studies, in 4 lessons, and they're really in quite some depth. Module 6 is Thermodynamics of Nuclear Power Generation, in 2 lessons. The course Corrosion and Degradation of Materials in Nuclear Energy Applications is somewhat parallel, and there is some overlap because they are freestanding courses. It provides a comprehensive study of corrosion and degradation of materials used in nuclear power reactor systems. It covers corrosion and irradiation effects in general, and then proceeds to a much more detailed discussion of stress corrosion cracking and hydrogen embrittlement, degradation of ceramics and polymers in the nuclear environment. So it's fairly comprehensive in this area. There are a number of case histories concerning specific areas of corrosion and degradation in the real world that are discussed in depth. And it also covers in this course the mitigation measures that can be taken to minimize corrosion and degradation, non-destructive and other analysis tools, and preventive maintenance. The course modules are 5 of them, and they're in 17 lessons. Module 1 is Introduction to the Nuclear Environment, so there's an overlap with the first course, which is 1 lesson. Module 2 is Corrosion and Degradation of Metals and Alloys in 5 lessons. Module 3 is Corrosion and Degradation of Ceramics and Polymers, 2 lessons. Module 4 is Corrosion and Degradation Case Histories in 6 lessons, where we look at real-life examples of some of the problems that are, or phenomena that are discussed in the first 3 modules. Module 5 is Testing Methods and Mitigation of Corrosion and Degradation. This is once again is equivalent to a full semester university course, and of course was taught as such in the classroom at the University of Kansas. The course format used for both these courses are that they are pre-recorded and they're presented in PowerPoint format. All the lectures are available over the internet on demand at any time and as often as desired by the student. So there's no set schedule, there's no demands to go to any place, go to a classroom, or tune in on the internet at any particular time. It does require a high-speed internet connection, which of course is generally not a problem. The instructors for both these courses are available live and via email for support, and by the phone as well. So there is support available to students at any time. Online quizzes are provided for progress evaluation. They're automatically graded, and any of the questions that require input from the instructor is provided as well. There is a prerequisite for taking these courses, and that is a college level course in material science, which many engineers, not necessarily most, but a large number of engineers have had. If they have not, then there is a course available from University of Kansas Continuing Education. It's entitled Fundamentals of Material Science and Engineering, and on this, just right here, we have the link to the page at Continuing Education that talks about this course. The instructors are myself, Carl Frame. I am a material science adjunct at the University of Kansas. I also have a consulting business, and I am the prime instructor in both of these courses, Materials for Nuclear Energy Applications and Corrosion and Degradation of Materials in Nuclear Energy Applications. The second instructor is Ronald Doherty from the Mechanical Engineering Department. He is a professor and was the former department chair of Mechanical Engineering Department at the university. And he is the instructor for the thermodynamics module in Materials for Nuclear Energy Applications. My contact information is given here. 2 email addresses, my personal at prodigy.net and my KU email address as well, and my phone and cell phone numbers. So if you have questions, don't hesitate to contact me. I'll be glad to talk to you, and we can provide you with copies of the detailed course outlines whenever you want it. So give a call, send me an email. I'll be glad to forward that information to you. And thank you for taking the time to listen to this brief video.